One type of word problem that you can solve with systems are money problems. Recall that you need two equations if you have two variables. So let's take a look at this situation here, and let's take a look at two variables. I have two different items, tacos and tostadas. And then notice that I have two different equations. I have an equation for me, and then I have an equation for my friend. And so we're going to try to figure out what the price is for each of these items. And you can see that creating two equations based on the information. Here is the money that I spent. I ordered 2 tacos and 2 tostadas, and my friend spent $13.76, 1 taco, 3 tostadas. And you'll see that down here I'm specifically naming my variables. Now in this particular case, since we don't really have a cause and effect relationship, we can really randomly assign X or Y to either one of these items, the tacos or tostados. And the reason, hopefully you can see why I chose Y for the tacos, is because if I wanted to put these in Y equals mx plus b, notice that I could go t equals negative 3a plus 1376. It'd be really easy to solve for t. In this equation here, it doesn't make any difference. Neither one is easier to solve for t, but because the second equation is easy to solve for t, I'll just make that my y variable. So a little bit of strategy there. Now, when we use Desmos, we don't need to put them into y equals mx plus b necessarily. So let's take a look at the equations in Desmos. And you'll see that I have left them in relatively standard form, just the way that I wrote them out. 2y plus 2x equals 1356. And of course what I'm looking for is the intersection. 349 and 329. Now we've got to be careful because I got to remember which one was x and which one was y. So $349 for x, $329 for y. So the tacos are $329, the tostados are $349. Let's do a very similar problem, and I'm going to do this problem on purpose. So you see the difference in defining your variables. So we're back at Taco Bus, but now we're dealing with breakfast burritos and tacos. And now we have a slightly different situation. I'm giving you the prices of each. Remember, in the previous example, we were looking for prices. And you can see that I underlined the specific definition of my variables. I didn't want to know how many tacos. I already knew how many tacos I bought. It told me right in the beginning. I bought 2 tacos and 2 tostadas. My friend bought 1 taco and 3 tostadas. So what I was looking for is the price, the cost of each. Notice how this situation is changing. I'm telling you the cost, and then what I'm giving you is a total. So my friend and I together ordered 7 items for a total of 23. And we're going to be answering this question now, how many? So notice how the equations change. Notice now I now have what I call a number equation. This is the total number of items that we bought together, and a money equation, which is the total amount of money that we both spent together. So notice the definition of my variables. T for taco, B for burritos, but I'm not looking for cost anymore. I know what these items cost. I'm looking for the number of each. So the two different equations change slightly. So let's put those into Desmos. So we have y plus x equals 7. and we have 2.25y plus 4.49x equals 20.23. So now we have a new point of intersection, which is 2 and 5. Once again, make sure you keep straight the x's and the y's. X is 2 and y is 5. 2 burritos, that was my x variable, and tacos is 5, my y variable. And let's take a look at this final question, which doesn't deal with money at all, but it's sort of like money. We're going to pretend that the points is our money. This could easily be $2. Hey, maybe I pay you for all of the correct answers that you get on a test. Wouldn't that be nice? So points and money, some kind of currency, some kind of a reward system. So the same thing is happening here. We have 2-point questions, and we have 5-point questions, and we have a total of 50 questions. So once again, I don't need to know money. I know how much the questions are worth. They're worth 2 points and 5 points. So I'm looking for the number of 2-point questions and the number of 5-point questions. Let's take a look at the equation. So once again, we have a total. There are 50 total questions. Some questions are worth 2 points, some questions are worth 5 points. And then we have the money equation. In this case, it's just total points. 2 points or $2, 5 points or $5 makes a grand total of 145 points or $145. It's the same exact idea. And so once again, it doesn't really matter which one we make X or which one we make Y. So let's say T, once again, is our Y variable, F is our X variable, and so let's go to Desmos, and we've got Y plus X equals 50. That's the total number of questions. And then we have 2y plus 5x equals 145. And all we have to do is zoom in such a way that we can see the intersection. And we're looking at 15 and 35. Remember that 15 is x and 35 is y. So there were 35 2-point questions and 15 5-point questions. You can see that these two numbers, obviously we can do the math in our head, add up to 50. And in addition, if we were to plug them into our point equation or our money equation, we could do that math pretty quickly as well, and we could see that we got to 145 points.